Hello world, welcome back to this tutorial on building a professional network using Linux. Now, in the last video I've explained how networking works fundamentally, and in this video I want to expand on that a bit, and I want to talk about the topic of virtual networks. The thing is that in a really huge network with hundreds and thousands of machines, you often don't want to allow every machine to talk to every other machine, okay? Because of security reasons, for example, and also we've seen that a broadcast is sent to every other machine in your network, and that's, I mean, with today's machines, with today's networks, they are really fast, so that isn't that much of a problem anymore. But still, I personally, I'm a minimalist, so if we can just remove some broadcast traffic, then that makes me happy. And but yeah, the main reason why you would want to suppress communication between some machines is really the security. For example, printers are known to be often very vulnerable to attacks. So something that could happen is that your printer gets infected with something, and from that point on, your printer could attack your other machines constantly. Okay, and printers, I don't think you would find a virus on your printer, right? I don't think there even are any antivirus solutions for printers. But still, printers can get infected with malware, and then they become a security problem for the rest of the network, because they can attack the rest of your network unless you do something against that. Okay? Virtual LANs or virtual networks, VLANs, allow you to subdivide your network and create sub-networks, if you will, and then you can really control the communication between these networks. But yeah, let's first look at how that works. So when you use VLANs, then you don't have to, but you can assign a number to each of these ports, like say number 3 and number 4 here. You can have the same number multiple times, 3, 4, 3, whatever. And the cool thing at this point is that if you send data in through a port that is configured to be on VLAN 3, for example, then it gets tagged, and that just means that your Ethernet frame will get a little information in there that says, hey, this is for VLAN 3, okay? And then it still gets routed as normal, but the switch, so let's say we have again 10, 1, 1, 10, and 10, 1, 1, 11, okay? So let's say I want to send some data from 10, 1, 1, 10 to 10, 1, 1, 11, but this one here is on VLAN 3 and this one here is on VLAN 4. What happens is the package that you are sending gets a so-called VLAN tag saying that, hey, this is on VLAN 3, okay? Then it's routed as normal, so it would go through this port here over to this switch, and then this switch will say, okay, I have this device that you want to talk to on this port, but this is a VLAN port also, and it has number 4. Number 4 is different than number 3, therefore I'm just gonna dispose of this packet and throw it away. Okay, so like this, you can take a lot of control of who can communicate with who. Okay. Now, one thing we need to be careful about is if I'm trying to communicate with VLANs through across multiple switches, then you have a problem, because normally a switch that gets a packet, like if this switch gets a packet from here, and it sees, hey, this has a VLAN tag, it will just immediately dispose of this packet in the first place for security reasons, because normally you don't trust the machines that are just there on your network ports. And yeah, this is really a security feature, because you wouldn't want a computer down here, if it's infected or something, you wouldn't want to allow it to send packets with the VLAN tag already set. Okay, so if you allowed that, then then every computer could just decide on its own which VLAN it wants to communicate on, and this is not something that you want to allow for security reasons, right? Because otherwise, for example, an infected printer again could just say, hey, I will just send something to a different VLAN, and you couldn't do anything about it, right? So what you do instead is you have to mark all the ports on which you allow tagged packets. So on this switch, you would say, hey, this is a trunking port, a so-called trunking port. And on this switch, you would say this is a trunking port because, this is another switch that the data is coming from. So I can allow these VLAN tags coming from this port. Okay. But keep in mind that this VLAN tag, this is still a regular Ethernet frame. Okay, so the VLAN tag is just one specific offset in there. It's that's not a completely different protocol you're speaking here. Okay, so you're still exchanging regular Ethernet frames back and forth, and this trunking really only says that you allow this tag to be set on packets that are coming from there. Okay, so if you turn trunking on a port that that doesn't in any way kill your connection, so let's say you are on this machine, and if you turn trunking on this port first, it doesn't cut your connection to this switch, so that you cannot set trunking on this port. So after activating trunking here, you still can communicate with the other switch fine. Okay. So now when you are subdividing your network with these VLAN tags, then you kind of have to stop thinking of your network in terms of this physical reality here, and you have to start thinking about that on a logical level. Okay, so you would have your VLAN 3, your VLAN 4, which would somewhat correspond to one huge switch that spans across your entire company. At least that makes things easier. And if this switch is on VLAN 3, it's as if you are connected to this VLAN switch here, and this one is connected to VLAN 4. So it's as if you are connected to this virtual switch here. Okay, and yeah, this allows you to think about your whole network in a completely different way. Okay, so at this point you can really control your connections on this logical level, and you don't have to have network cables running across the room and stuff like that. So you can do all this this messy connecting stuff. You can do that logically in your VLAN settings, and that allows you to connect your network in a much cleaner way, and then do this messy stuff with connections digitally. Okay. This here is a TP-Link TL-SG108E switch. Now, obviously, this is not industrial strength, okay, but yeah, I didn't want to spend something like 3,000 bucks on an industrial strength switch for this video series. But yeah, this switch offers most of the features that I want to talk about, so I think it's a pretty good choice to take this one. It's also a pretty popular switch as far as I can tell. So yeah, why not take it? Mainly I'm interested in the VLAN options here. It also has some other features that I want to show, but in this video we will concentrate on the VLAN features. So yeah, let's plug this in. Okay. And yeah, this cable here goes to the rest of my network. So I'll plug that in. Okay. So now I'm connected to the rest of my network. And now I will connect my laptop. To this switch on port, let's take 3. Okay, I'll disconnect from the Wi-Fi so that I don't get some mysterious results. Okay. Now here I have a freshly installed Raspberry Pi, which I will also connect to the switch on port 4. Now this switch also does a DHCP request when you plug it in, and yeah, it then gets an IP address from my router, my Fritzbox. And here I have logged into my Fritzbox, went to home network to get the IP address. Okay. It was 192.168.178.46. Okay. So here is the login on that switch. The default credentials are admin and password admin, but it forces you to set a new password immediately. So I have already generated one randomly. Okay, so here I'm now logged into this switch, And over here on this other tab, I'm connected to another switch of the same model, which is actually on the other end of this cable here. So yeah, this cable now connects two of the same model. And so here we can now go to VLAN. Now we could go here to port-based VLAN and assign a VLAN to each port, but I think a better way to do it is using this 802.1q VLAN, which just gives you more control over the whole thing. So let's see, port 7 here is, so I've configured this here already to use VLAN. I'll do it over here too. Okay, enable, apply. Okay. So now VLAN is turned on both switches, and yeah, here port 1 is the port that goes from this switch to the other switch. Okay, so here I would configure it to use tagged VLAN, because I allow the other switch to give tagged Ethernet frames to this switch. So let's see, I will just configure 3 VLANs, okay, 2, 3 and 4. I need to do that on both switches. And yeah, now I set port 1 to allow tagged Ethernet frames to come from there with VLAN 2. Same for VLAN 3. And VLAN 4. Okay. So as you can see down here, I now have VLAN 2, 3 and 4 on this switch. And yeah, port 1 is allowed to receive tagged Ethernet frames for these VLANs. Okay, so if the other switch sends a tagged packet for one of these VLANs, then only then will this switch accept it. Over here on the other switch, I have to add the same things. Wait. On the other switch, I have that on port 7. So for VLAN 2, I need to take port 7. Okay. Okay, so now the two switches both have VLAN 2, 3 and 4, and they are allowed to exchange tagged Ethernet frames for these VLANs. Okay, so I have not put anything into these VLANs yet, but now the switches allow these VLANs. Okay. Now let's put something in one of these VLANs, okay? First thing I will do is I will ping the Raspberry Pi. It has a host name netcore. And yeah, I can ping it, okay? I'll go to VLAN 4 here and put port 4 into that VLAN. Now notice port 1 I had put in as tagged VLAN, and port 4 I've now put in here as untagged. The difference is with a tagged VLAN, the other switch sends a tagged Ethernet frame and the switch accepts it. Okay. If I put this on untagged, it means that when the switch gives the Ethernet frame out to the device, it removes the tag. Okay. So if I say add modify now, port 4 is now in the VLAN 4. If I ping it again, it still works. Okay, what's going on here? I said that VLANs are really isolated, and now I'm able to communicate with the device on a different VLAN. That shouldn't be possible, right? So what's the deal here? Well, I have to admit I've oversimplified things a bit. You see, in reality, ports don't have only one VLAN assigned to them. I mean, in port-based VLANs that would be the case, but we've decided to go with 802.1q VLANs. And in 802.1q VLANs, ports can have multiple VLANs. So this port here, for example, can be part of VLAN 1, 3, and 4, for example. And that then means if a packet for this port arrives, then if the tag is 1 or 3 or 4, then the switch will give it out to the device. And yeah, in the other direction, that doesn't really make sense, because when you send something into the switch, it wouldn't have any way to decide which VLAN tag to tag it with. Okay, so that's the other number here. So that only really allows one VLAN that you put on a packet when it comes in. Okay, and that's what's going on here right now. We've only assigned the port to two VLANs to be allowed to receive from these VLANs, but it's not sending to these VLANs yet. Okay. So these 802.1q VLANs are a bit more complicated than I told you before, but yeah, that also gives you some interesting possibilities as a side effect. You can put one device in one VLAN, another device in another VLAN, but then assign the VLANs to each other as receiving VLANs, so 3, 4 and 3, 4. So this device then sends through VLAN 4. This device receives on VLAN 4. This device sends on VLAN 3. This device receives on VLAN 3. So although they are in different VLANs, they can communicate directly with each other. Okay, and they would even receive each other's broadcast messages. But that's not normally what you want to do, right? Normally you want to take control over which device can communicate with which device on which port. And yeah, when you have an approach like this, then you cannot limit the ports anymore. So I don't really see many good use cases for that, except something rather common is to have something like an outside VLAN, oftentimes VLAN 1. Okay. And yeah, you would put the computers of your administrators into this VLAN. Okay. Okay. And yeah, then you would configure all your ports to be allowed to receive from VLAN 1 and its own VLAN. Okay. And then you would configure this port to be allowed to receive on all VLANs, 1, 2, 3, 4, and send on VLAN 1. Okay, that way your admins can send data to every machine. Every machine can answer to the admin. So your admins are kind of like in all VLANs at the same time, if you want. But that also brings another problem, because if your admins are in VLAN 1, then they would have IP addresses like 10.1.1. something. Let's say 10. And now this is outside of the network subnet range of your subnets that are running on your VLANs. So they wouldn't even try to communicate with this machine directly. They would try to communicate with a router instead. So what you can then do is you can configure your DHCP server to give a static route to all the clients, which says, okay, 10.1.1.0/24. So your VLAN 1 subnet range should be on link. Okay, and we'll discuss what that means later, but with such a static route coming from the DHCP server, these devices will then be able to communicate with VLAN 1 directly, and yeah, the admin machines would then need to have a static route for 10.1.0/16 to be on link. So that everything that goes to any VLAN would be communicated directly and not go through some router. That's actually down here in this setting, because when port 4 sends something out, it still sends that to VLAN 1. Okay, so you need to go to this PVID setting, select the port 4 in this case, and now I've told the switch that data that's coming in from port 4 is supposed to be put into VLAN 4, and now if I try to ping it, I'm not getting an answer, because I can still send the packet to the Raspberry, but now it cannot answer anymore. Now I could solve this issue by also putting the laptop into VLAN 4, but there's no DHCP server in VLAN 4, right? So I want to show you one more quite cool thing about VLANs. Right now, all the machines have these physical network interfaces, right? And yeah, since every machine has this one network interface, they can only be connected to one switch, which has one VLAN assigned to it, or one primary VLAN. And imagine you want to have a device that communicates with things in multiple VLANs. Okay. For example, some server that's supposed to be there for everybody in each VLAN. Okay. Now you could just buy additional network interfaces and build them into your machine, and then connect them to multiple ports, but there's an easier way to do this by using virtual ports. Okay. So what we will do now is we will take the Raspberry Pi. Okay, and connect it to one switch port. Okay, but we will configure the Raspberry Pi to pretend to be a switch itself. Okay, and then the Raspberry Pi will be able to put VLAN tags on its Ethernet packets, so that the Raspberry Pi itself can decide which VLAN it wants to talk to. Okay, and yeah, for this to work, we then need to configure that port as a trunking port. Okay, otherwise the switch wouldn't allow that. And then on the Raspberry, we will configure multiple virtual ports, and each of these virtual ports will be on a different VLAN. Okay, so we will have one on VLAN 1, one on VLAN 3, one on VLAN 4. Okay, and yeah, they all need their own separate IP addresses. So this one here will get 10.1.4.254. This one will have 10.1.3.254. And this one would have 10.1.1.254. Okay? And that's pretty cool to have a device be able to communicate with all VLANs and have an own IP address in each of these VLANs. I want to install a DHCP server on the Raspberry Pi, but in the next video. So this will require the Raspberry Pi to have fixed IP addresses. So I'll put the Raspberry back in VLAN 1. So now I can connect to it with SSH. Okay. So let's configure the Raspberry Pi to have static IP addresses. Okay. First thing you need on the Raspberry is you need to install the package Vlan. Okay. Okay, now that we have installed the VLAN package, we can now create the network interfaces. So first we can look into Etsy network interfaces. In here you can see that the network interfaces are created by going through all the files in the subdirectory interfaces.d, and they are included here. So we can now create an interface by creating a file in here, for example called VLAN2, and here we put in auto ETH 0.2. Okay, so this .2 tells the Raspberry or the Raspberry Pi OS that you want this to be on VLAN 2. And we are configuring it statically. This is a backend device that we are using for the communication. So we will put VLAN tags with number 2 on our packets and send them out through ETH0. Okay. Now we just have to give it an address, 10.1.2 for the VLAN 2. But this is quite arbitrary, but you really should have this should really be consistent, okay? I think it's really a good way to have the third byte of your address to be the same number as your VLAN tag, okay? /24 to set the network mask, okay? Okay. Okay, for VLAN 3, the interface needs to be .3, and the IP address will be with a 3 in the third byte. And for VLAN 4, a 4. Now restart the network. Okay. And let's look into the network configuration. Yes, this is looking very good. So here we have these new interfaces that are communicating through interface 0, and they have the desired IP addresses. The Raspberry is now technically a switch, a VLAN enabled switch, so we need to tell our switch over here that port 4 is now a trunking port. Okay, now let's see if we can reach the Raspberry Pi from the laptop through one of these VLANs. So VLAN 4, I will put port 3 into that VLAN. Okay. Now it's a bit surprising to me that I can still communicate with the switch here. Yeah, apparently the switch will take packets from any VLAN for the communication here, but actually the IP address that I'm communicating with shouldn't be reachable from my laptop because yeah, I'm in a different VLAN now, and I don't have a DHCP server in that VLAN, so I shouldn't have an IP address at this point. That's generally a problem about VLANs. If you change a VLAN on a switch, the device that's connected gets no notification about that. So you really have to unplug the device and plug it back in so that it tries to get a new IP address. It would fail here, but yeah, a different way you could do that is you could go to the port and turn it off. In this case, that would be a bad idea because then I cannot communicate at all anymore because that's a port that I'm using here. So, but if you are doing this for different devices, turning a port off and then on again is a good idea, a good way to trigger the device to get a new IP address. Okay. Good. Okay, now I'll unplug this. Okay. Now it figured out that it is not connected anymore. Now it's trying to connect. I can see an LED blinking, so something is going on. But it will fail to connect, of course, because there isn't much in this VLAN 4 to talk to right now. So I will go to the connection settings here and change this to a manual configuration. I will give it an IP address 10.1.4.10, for example. So it must be in the same range, 10.1.4, so that I can communicate with the Raspberry. Okay. Now I have an IP address which inside VLAN 4 is compatible to the IP address that the Raspberry has in VLAN 4. Connection was activated. That's looking good. But it tells me that the connection is limited because I don't have access to a DNS server, to a router. I cannot communicate to the outside world. I don't have internet access. That's what this message means. Okay, so let's see if I can now ping 10.1.4.254. And I can ping it. Good. So, yeah, the Raspberry is now communicating on VLAN 4. This is configured to be on VLAN 4. Yeah, this is really nice. Of course, now I cannot change the settings back because the port is now configured to be on VLAN 4, and in that VLAN I don't have an IP address that would be compatible to the switch's IP address. So what I can just do is unplug, plug into a different port, set this to DHCP again, disconnect, reconnect. Okay. And yeah, I'm back in VLAN 1. Okay, that's all I wanted to show you today. I think VLANs are a really cool thing. As I told you, the switch that I'm using is not industrial grade, okay? So here I really have to set all the VLANs manually. In an industrial grade switch, you have some more freedom and it does more for you. For example, you can, on an industrial switch, you can, for example, set the VLAN based on the MAC address. And that's a pretty cool feature because imagine this guy here is some rogue person who's trying to infiltrate you. And he just goes to your switch, unplugs, plugs himself into a different switch, and now he's communicating to a different VLAN. You might not want that, right? I mean, you typically would put switches behind a locked door, but yeah, still, something could happen and somebody would then be on the wrong VLAN, and that's not what you want. Okay, so if you take this device, plug it somewhere else, then the switch will just reconfigure itself and change this 4 to a 3 automatically. Okay, because it will say, hey, that's this device is supposed to be on VLAN 3. I won't let you talk to VLAN 4, I reconfigure this to be on VLAN 3 now. And there's even crazier stuff than that. You can even assign the VLAN based on the Windows authentication. Okay, so you cannot even go to a different computer, log in, and be on a different VLAN, because yeah, as soon as you've logged in with your account, you are being put into the VLAN where you belong, and yeah, so even by going over here, this rogue person is not able to get into VLAN 4, because as soon as he logs in on this machine, the switch will say, hey, this is coworker John Doe, and he's supposed to be on VLAN 3, so I'm changing this 4 to a 3 again, and yeah, stuff like that. As I said, I think VLANs are really an interesting topic, and they give you really interesting features and capabilities. So I think this is really a topic that you really need to know, and that's all for today. If you like this video, like it, share it, subscribe, and see you next time.